Good evening, students. Today we are going to study laws of chemical combination. There are five laws. There are five laws of chemical combination. These five laws tell us elements how elements combine to form compound. One by one, we are going to see all the five laws. The first major law is law of law of law of conservation of mass. This law says that mass cannot be created or destroyed. Mass is always conserved. For example, the element A and B combines to form the compound AB. So the sum of mass of A and B will be equal to mass of the compound AB. That means sum of masses of reactants is equal to sum of masses of products. Sum of mass of reactants is equals to sum of mass of products. This is law of conservation of mass. Now let us understand it through an example. For example, carbon plus oxygen gives us carbon dioxide, CO2. We know that atomic mass of carbon is 12 and oxygen is 16. So here carbon mass is 12 and oxygen it is 16 into 2, that is 32, and CO2 it will be 12 plus carbon plus 16 into 2. So it will be equals to 44. So if we add the mass of the reactants, it will come out to be 12 plus 32 equals to 44. And mass of the product is also 44. So this means mass of sum of the masses of reactants is equals to sum of masses of products. Here we have only one single product, that is CO2. But this law is not valid today. This law is not valid today because we know that E is equals to delta mc square. That means energy can be converted into mass or mass can be converted into energy, right? So this law is not valid today. It was valid in 1740 or 1760. So this is a very old law. Now let us do one problem on this law. So write down the question. Write down the question. .5 gram of C2H6, that is ethane, on complete combustion gives 44 gram of carbon dioxide, that is CO2, and 2.5 7 gram of H2O, that is water. Show that the reaction obeys law of conservation of mass. Now let us solve the problem. We are given that ethane, that is C2H6, on combustion, means on reacting with oxygen, gives us carbon dioxide, CO2 plus water plus heat. So let us balance the reaction. So there will be 7 oxygen and 4 CO2, 6 H2O. So there are 4 carbons. There are 4 carbons on the reactant side and 4 carbons on the product side, and 12 hydrogen on the reactant side and 12 hydrogen on the product side. 14 oxygen on the reactant side and 4 into 2, 8 plus 6, 14 oxygen on the product side. So our reaction is balanced. Now we are given that ethane is 1.5 gram. Ethane is 1.5 gram and water is 2.7 gram. And carbon dioxide is 4.4 gram. So in the question, make the correction here. The carbon dioxide given is 4.4 gram. Now we know the amount of ethane. From this we can find the amount of oxygen. For that, we know that number of moles of any compound is equals to mass divided by molar mass, right? We know the formula. So here, if our compound is ethane, here our compound given is ethane. So for ethane, the mass given is 1.5 gram and molar mass will be there are 2 carbons, so 12 into 2, 24 plus 6 hydrogen, so 24 plus 6, 30. So divided by the molar mass, that is 30. So number of moles will be equals to 15 divided by 300, that is equals to 1 by 20. 1 by 20, or we can say 0.05 moles, right? So these many moles we have these many moles of ethane. So from this we can find out the moles of oxygen. So here we see for 2 moles of ethane we require 7 moles of oxygen. So let us write it down that 2 mole of ethane C2H6 requires 7 moles of O2 oxygen. So 0.05 moles of C2H6 will require 7 by 2 into 1 by 20, that is equals to 7 by 40 moles of oxygen. Moles of oxygen, that is O2. So we know that number of moles equals to mass divided by molar mass. Molar mass. Number of moles equals to mass divided by molar mass. So we know that number of moles of oxygen is 7 by 40 and we need to find the mass. So mass divided by molar mass of oxygen is 32. So this implies that mass of oxygen, that is O2, is equals to 7 by 40 into 32. So 4 1 ja 4, 0, 4 8 ja 32. So this is equals to 5.6 gram. So mass of oxygen is 5.6 gram, right? So from here, we can find the total sum of the mass of the, from here, we can find out sum of the mass of the reactants. And we'll check whether it is equals to sum of the mass of the products. Okay. So here mass of ethane is 1.5 gram and mass of oxygen is 5.6 gram. So if we add both the masses, we will find out that 1.5 plus 5.6 is equals to 7.1 gram. So this is the mass of the reactants. And if we find the sum of the mass of the products, we will find out it to be 4.4 plus 2.7, that is 7.1 gram. So we can say that sum of the mass of the reactants is equals to sum of the mass of products. So that's what we need to show. We need to show that the reaction obeys law of conservation of mass. Law of conservation of mass says that mass of sum of the mass of reactants is equals to mass of the products. So here we have sum of the mass of reactants, that is 7.1 gram, and mass of sum of the mass of the products, that is 7.1 gram. So we can say that this obeys the law of conservation of mass. Now we will go ahead with the second law. Second law is law of definite proportion. Law of definite proportion. Law of definite proportion says that irrespective of the source of a compound, the ratio of the elements by mass will be same irrespective of the source. Now, if you take water, whether sea water or you take rainwater or you take tap water, the elements in all the three waters will be hydrogen and oxygen. Now, if you find the ratio of hydrogen and oxygen in all the three waters, you will find it to be, as it is, there are 2 hydrogen in H2O. So mass will be 2 and for oxygen it will be 16. And for rainwater, same 2 and for oxygen 16. In tap water also, hydrogen mass 2 and oxygen mass 16. So ratio will be 1:8. In rainwater also ratio will be 1:8. And in tap water also ratio will be 1:8. So irrespective of the source, the ratio of the elements by mass is same in all the three. That is what law of definite proportion. In NCERT, we are given the example of cupric carbonate. That means the ratio of copper, carbon and oxygen will be same whether you take cupric carbonate from India or Australia or America. The ratio of the elements by mass will be same in India also, in Australia also, in America also. That is the law of definite proportion by mass. Now let us do one problem on it. Write down the question. 0.243 gram of magnesium on burning with oxygen yield 0.4030 gram of magnesium oxide. Let us see, this is the experiment number 1, and from the experiment number 2, 0.182 gram of magnesium burning with oxygen gives 0.302 gram of magnesium oxide. Now, now let us write for experiment 1, then for experiment 2, magnesium amount, oxygen amount, and magnesium oxide. So from the experiment number 1, the amount of magnesium given is 0.243 and amount of magnesium oxide given is 0.403. Now you can calculate the mass of oxygen. You can subtract 0.243 from 0.403, so it will be 0.160. Now in experiment 2, we are given the amount of magnesium, that is 0.182, and amount of magnesium oxide is 0.302. So we can calculate the amount of oxygen. So subtract 0.182 from 0.302. So it will come out to be 0.120. So amount of oxygen in experiment 1 is 0.160 gram, and in experiment 2 it is 0.120 gram. Now let us calculate the ratio by mass of magnesium and oxide by magnesium and oxygen in experiment 1 and experiment number 2. So in experiment 1, if we calculate the ratio of mass of magnesium and oxygen, it will come out to be 0.243 divided by 0.160, that is 3:2, or approximately 1.51. So ratio is 3:2. And in experiment 2, ratio of mass of magnesium and oxygen is equals to 0.182 divided by 0.120. That also come out to be 3:2. That means there are 3 parts of magnesium from 5 parts of magnesium oxide. So in both experiment 1 as well as experiment 2, ratio of mass of magnesium and oxygen is same. So we can say that this follows the law of definite proportion by mass. Now let us go to the third law. Third law. Third law is law of multiple proportion. Law of multiple proportion. Now, first let us write the definition of the law of multiple proportion. Then we will understand it step by step. Okay, the definition is when two elements combine to form more than one compound, then the different masses of one element which combines with fixed mass of other element bears a small whole number ratio to one another. Now this definition seems complex, but we will understand it step by step. Now let us take the example of carbon and oxygen forms carbon dioxide, or another, let's say carbon and oxygen combine to form carbon monoxide, that is CO. So in the first case, the mass of the carbon is 12 and oxygen is 16. But here you see in CO2 there are two oxygens. So we require two oxygen here. So 16 into 2, that is 32. And here we can say that to form CO2, carbon and oxygen combines in the ratio of 12:32. And then in the second case of carbon monoxide, carbon and oxygen combines in the ratio of 12:16. So here we can see that the mass of carbon is constant, means different masses of oxygen, that is 32 and 16, are combining with the fixed mass of the other element, that is carbon, and the fixed mass is 12 gram. So ratio in which they combine, that bears a small whole number ratio to one another. Now let us calculate that small whole number ratio. Now see, different masses of oxygen, that is 32 gram and 16 gram, which combines with fixed mass of carbon, that is 12 gram. So they combine in 32:16, that is 2 divided by 1, that is 2:1 ratio they combine. Now let us take another example of H2O, water, and H2O2, that is hydrogen peroxide. So in case of H2O, hydrogen and oxygen combine in the ratio of 2:16, and in H2O2 they combine in the ratio of 2:32. So here we see that the fixed mass of the, here, just a minute, Here they combine 2:16. Here the mass of the hydrogen is fixed, that is 2. And the different masses of oxygen, that is 16 and 32, combines with the fixed mass of hydrogen, that is 2. So they combine in a simple whole number ratio. So we can write it different masses of oxygen, that is 16 gram, and 32 gram, which combines with fixed mass of hydrogen, that is 2 gram, bears a small whole number ratio. So here oxygen is combining with hydrogen in the ratio of 16:32. That is 1:2. So this is a small whole number ratio, right? 1:2 is a small whole number ratio. Now let us make our understanding more clear by taking another new example. For example, we are given nitrogen and just a minute. We are given nitrogen, oxygen, oxygen, we are given nitrogen, oxygen. Okay, let me quickly draw the table and then we'll see. We are given masses of nitrogen, oxygen, and the compound formed by the combination of nitrogen and oxygen. So let's say first compound formed is N2O, second is NO, and third is N2O3, and the fourth is NO2, and fifth is N2O5. So we are given these 5 compounds. So in these 5 compounds, in the first compound, N2, so mass of nitrogen will be 14 into 2, that is 28 gram, and oxygen it will be 16. In the second case, there is one nitrogen, so mass will be 14, and oxygen will be 16. And in the third case, there are 2 nitrogen, so mass will be 14 into 2, that is 28, and there are 3 oxygen in N2O3, so mass will be 48 gram. In the fourth, NO2, the mass of nitrogen will be 14 and mass of oxygen will be 32. In N2O5, mass of nitrogen will be 28 and mass of oxygen it will be 16 into 5, that is 80. Now, if we now let us fix the mass of one element. Let us say we will fix the mass of nitrogen. We will fix the mass of nitrogen. So in N2O, the mass of nitrogen is 28, and it combines with oxygen, that is 16 gram. In the second case, NO, the mass of nitrogen is 14. So we are fixing the mass of nitrogen. So if we make it to 28, so we will have to take 2 nitrogen. Means we have to multiply this 14 by 2. So then if we double the nitrogen, then oxygen will also get doubled. Now let me write nitrogen 28, so oxygen will be 32. In the case of N2O3, so nitrogen is already 28, so oxygen is 48. And in case of NO2, nitrogen is 14. So if we double the amount of nitrogen, we have to double the amount of oxygen, right? So nitrogen 28. So oxygen will be 32 into 2, that is 64 gram. In N2O5, nitrogen is already 28. So oxygen will be 80. Now, if we calculate the ratio of the masses of nitrogen and oxygen in which they combine to form the different elements like N2O, NO, N2O3, NO2, N2O5, we will find that they will combine in a simple whole number ratio. For example, if we calculate for N2O, so means that here mass of the nitrogen is fixed. Different masses of oxygen are combining with the fixed mass of nitrogen. So they are combining in the ratio of 1:2, 2:3, 4, 5. So this is a simple whole number ratio. So this follows the law of multiple proportion. So if there are two elements, we'll say it follows the law of multiple proportion. But there is another law, that is hashtag law. It is called hashtag law. It is not given in the NCERT, but nowadays it is being asked in the competitions. So I am going to tell this law to you. That is called hashtag law. Its name is law of reciprocal proportion. Reciprocal proportion. Now, first let us write the definition of this law, and then we will understand it step by step. First, when two elements combine separately with a fixed mass of third element, then the ratio of masses in which they do so bears a small whole number ratio to the ratio of masses in which they themselves combine. Combines. Now, this seems to be a confusing definition, but we'll understand it step by step. You'll find it very easy. Now let us take example of carbon and sulfur. They combines with oxygen. So if carbon combines with oxygen, it will form CO2. If sulfur combines with oxygen, it will form SO2. Here in CO2, carbon and oxygen combine in the ratio of 12:32. And in SO2, they combine, sulfur and oxygen combine in the ratio of 32:32. Now carbon and sulfur combines separately with fixed mass of oxygen in the ratio of masses, that is carbon is to sulfur, it will be 12:32. So here we can see that the mass of the oxygen, that is the third element, is constant, that is 32. So mass of carbon and sulfur ratio will be 12:32. So, or we can say 3:8. So they are combining in this ratio. Now, if I ask you, in what ratio carbon and sulfur will combine with each other? So they will form CS2. So they will combine in the ratio of 12:2. Sulfur is 32. So 32 into 2, that is 64. So they will combine in this ratio. So ratio of masses in which carbon and sulfur themselves combines, that is 12:64, or we can say 3:16. Now if I ask you to find the ratio of 3:8 to 3:16, it will be a simple, so it will be a small whole number ratio, right? It will be a small whole number ratio to the ratio of masses in which they themselves combine. So the ratio of carbon and sulfur is 3:16, and here carbon and sulfur combine separately with fixed mass of oxygen in the ratio of masses, that is 3:8. Now if I calculate the ratio, that is 3/8 divided by 3/16, it will come out to be 2 divided by 1, that is 2:1. So this is a simple small whole number ratio. This is what law of reciprocal proportion says. So if in question it is given that there are 3 elements, then we will say that it is law of reciprocal proportion. If there are 2 elements given, then we will say it is law of multiple proportion. So this is how you can differentiate between the law of reciprocal proportion and law of multiple proportion. Now, let me take one more example to make the understanding more clear. For example, sulfur and oxygen combine with hydrogen. If sulfur combines with hydrogen, it will form H2S, and if oxygen combines with hydrogen, it will form H2O. So here in case of H2S, they will combine in the ratio of 2:32. In case of H2O, they will combine in the ratio of 2:16. Here mass of the hydrogen is fixed. So sulfur and oxygen are combining in the ratio of 32:16, right? Ratio of masses of sulfur and oxygen which combine with fixed mass of hydrogen is equals to, that is 32 divided by 16, that is 2:1. Now ratio of masses in which sulfur and oxygen themselves combine. If sulfur and oxygen combines, what they will form? They will form SO2, sulfur dioxide gas. So they will combine in the ratio of 32:32. So sulfur is to oxygen ratio is 32 divided by 32. That is 1 divided by 1. So they are combining into 1:1 ratio. Now if we calculate the ratio of both these ratios, so it will be a simple small whole number ratio. Now let us go to the fourth law, that is Gay-Lussac's law. In the next video, we are going to see the remaining two laws. That is, fourth one is Gay-Lussac's law and fifth one is Avogadro's hypothesis. These are very simple laws. We'll complete these two very quickly in the next video. So till now, we have covered three laws. First one was law of conservation of mass. Law of conservation of mass. Second one was law of multiple proportion or definite proportion. Second law was law of definite proportion by mass. Third law was law of multiple proportion. I hope all the three laws are clear and we have done problems also on all the three laws which are possible in the competitive exams. I hope everything was clear to you. I hope everything is clear to you and I wish you all the best for the problems based on all these three laws. Thank you very much.